Okay, here are our solutions to the related rates worksheet from class today. The first problem, get a screensaver. Okay, you got a rectangle. There's this rectangle here, and I'll call the short side maybe L for length and the long side W for width, whatever. And what it says is there's a 3x2 rectangle, and it expands in such a way that the 2 centimeter side, which is what I'm calling L, is expanding at a rate of 4 centimeters per second. What that tells you is that this 4 right here is L prime. The proportions of the rectangle never change. That's an interesting statement that I'll get back to in just a minute. How fast is the area of the rectangle increasing? So it's asking for A prime when its dimensions are 12 by 8. So when its long side is 12 and its short side is 8, this tells me that I want its short side, which I'm calling L, to be equal to 8, and its long side, which I'm calling W, to be equal to 12. Wait, what happened to 3 and 2? Why are they 12 and 8 now? Well, the question's asking about the rate of change of the area, so it's asking me to find A prime. But it wants A prime at this point right here. So this is the only width and length that are relevant to the problem. We don't need this one up here. So we almost have enough information. You want to relate together the different letters, the different variables, although they're functions in this case. So the way I can do that is the area of a rectangle is the length times the width. And this gives me an equation relating together area, length, and width. What I really want is an equation relating together the rate of change of the area, because that's what it's asking for. So if I take the derivative of both sides of the equation, I'd have to use the product rule on the right-hand side. And I guess something like this. Note that L and W are functions, so their derivatives are L prime and W prime, respectively. So now all I got to do is plug in. Well, I want to solve for A prime. L prime I figured out earlier was 4. W I have written over here is 12. Plus L I figured out was 8. All I got to do is figure out W prime. It's a little bit tricky though. To figure out W prime, see, should I write this somewhere? You use the fact that the proportions of the rectangle never change. So because the proportions of the rectangle never change, it starts out so that the width is 50% bigger than the length. And I need the width to remain 50% bigger than the length. So if the length is growing at a rate of 4, I need the width to grow at a rate 50% greater than 4. In other words, W prime will be equal to 6. A little bit tricky that wasn't told explicitly that you had to figure that out. But once you know that, that goes in right here. And so I get that A prime is, 48 plus 48. So A prime is equal to 96. I'm not too concerned with units, but I guess in this case it would be centimeters squared per second. Centimeters squared because we're talking about area. Yeah, whatever, good enough. Okay, next problem. FBI agent. So there's this boat. There's my boat right there. And then there's this shoreline. There's my shoreline right there. And the distance from the boat to the shoreline is 400 meters. I'm going to write that as 0.4. Why are you writing that as 0.4? Because I'm going to use kilometers throughout this problem. Because they tell me this is 400 meters, but then later on they refer to these things in terms of kilometers. So I'm going to make everything kilometers. A gangster under surveillance is walking along the shore, assuming the shoreline is straight, and the gangster is walking at a rate of 2 kilometers per hour. So maybe I'll let, I don't know, G for gangster be the distance from this point to where the gangster currently is. So I get this triangle right here. Almost a triangle. Whatever, good enough. And so this tells me that G prime is equal to 2. How fast must the FBI agent rotate the spyglass? So we're talking about the change in an angle. So what I want to do is put an angle in here. Maybe I'll call it theta. So that I can come up with some sort of an equation that looks a lot like a 6. It's supposed to be a G. So I can come up with some sort of equation relating together the theta and the G. You might wonder, why was I able to put in 0.4 right here, but I can't put in 1 right here? Right? Later on it says that the gangster is 1 kilometer from this point. This distance G right here is 1. In fact, that's what this tells me, that G equals 1. But you can't change this G into 1 because this changes throughout the problem. The distance from the boat to this nearest point never changes. So I can just put in a 0.4 right here. but the distance from this point to where the gangster currently is does change, so I have to leave it as a letter, not a number. Similarly, theta changes. So even though I could calculate this angle theta right here, I don't want to put in that angle measure because this is going to change as this guy walks. Person. Do I know the gangster's a man? I guess it doesn't really say that. Anyways, so how can you relate together this and this g? Well, there's a few ways you could do it, but the easiest way would be to use the tangent function. You could say the tangent of theta is equal to, using SOHCAHTOA, TOA, tangent is opposite over adjacent. So that would be g divided by 0.4. And this equation right here, I can use to figure out what the question's asking me for. And the question's asking me, basically it's asking me for theta prime. How fast is this angle changing? So to get a theta prime, I'll take the derivative of both sides of the equation. The derivative of tangent of theta is secant squared theta times theta prime. It's a chain rule going on there. And the derivative of g divided by 0.4 would be g prime divided by 0.4. The reason I can do that is this 0.4 is just a constant. So you can think about it as 1 divided by 0.4 times g. So when you take the derivative, leave the constant alone, 1 divided by 0.4, and then take the derivative of g, which is g prime. That gets me here. Anyways, this is all I can figure out. Theta is equal to, if you divide both sides by secant squared, you get g prime divided by 0.4 secant squared of theta. But that's equal to, well, all right, I'll leave the 0.4. Do I want to leave the 0.4 in there? I don't want to leave the point. I'll leave the 0.4 in there. It would be g prime times, let's see, 1 over secant is cosine. So cosine squared theta divided by 0.4. At any rate, here's an equation that tells me theta prime in terms of some other stuff. If I could figure out this other stuff, I'd be done with the problem. I already know what g prime is. That's good. Here's a g prime. The only other thing I need is what's cosine of theta. Well, I can figure out cosine of theta. Let's see. Maybe I need to do it off to the side to find cosine of theta. I'll draw this little triangle. This is that same triangle over here where this is 0.4 and that's theta. But at this moment right here, when I'm trying to figure out cosine of theta, this distance is 1. G is equal to 1 here. So if this is 0.4 and this is 1, I can solve for this side. This is the square root of 0.4 squared plus 1 squared. In other words, that's the square root of 1.16. Which, I don't know, maybe you can simplify that. Can you simplify that at all? If you can, I don't want to. I'm going to leave it as the square root of 1.16. So now I can figure out what the cosine of theta is, because cosine is adjacent over hypotenuse. So cosine of theta is equal to 0.4 divided by this hypotenuse that I just figured out, the square root of 1.16. And now I have all the information I need over here. G prime is equal to 2. Cosine squared of theta, well, cosine of theta is 0.4 divided by the square root of 1.16, but I need that thing to be squared, and then divide the whole thing by 0.4. I bet that simplifies. Let's see, I'm squaring this fraction. Maybe I'll jump way over here. I'll direct you with an arrow. Okay, so I got my 2 from this 2. I square this whole thing, and I get 0.16, I guess would be one way I could write this. So 2 times 0.16 divided by, and then 1.16 square root squared just gives me 1.16. And then I want to multiply that by 1 over 0.4. I bet I could simplify that. Let's see, 0.16 is 0.4 times 0.4, so I cancel out this 0.4 with one of these 0.4s, and I'd have 1.4 left up on top, which I multiply by 2 to get 0.8 divided by 1.16. In other words, 8d over 116. Let's see, that reduces because 4 goes into both of those. So that would leave me with 20 divided by, this is making my head hurt, 29, I think. So all that to say that theta prime is equal to 20 over 29. I've completely ignored units throughout this problem. I guess I need to go somewhere. This is 20 over 29 radians per, let's see, all these units have been in hours. So this is 20 over 29 radians per hour. The question asked me to convert into degrees per minute. So I guess if I'm going to convert into degrees per minute, to change radians into degrees, I multiply by 180 and I divide by pi. And to change hours into minutes, which is what I want, well, let's see, you multiply by 60. So I'll multiply the bottom by 60, something like that for all of my conversions. Let's see, this 180 and this 60 can reduce to 3, and so I'm left with 60 over 29 pi degrees per minute. I'm not going to care a whole lot about units, but in this problem it did specify to change the units, so green would be the proper units, although for my purposes red is a perfectly good answer. Okay, moving on. This picture. I got a flood lamp, and here it is. And it's on the ground 200 feet from a vertical wall. There's 200 feet, and there's a vertical wall. A 6-foot tall man is walking towards the wall, so walking in this direction, at a rate of 30 feet per second. How fast is the tip of his shadow moving down the wall when he is 50 feet from the wall? So here's the person right here. He's 6 feet tall. There's the shadow. He's got a hat on or something. There's the shadow. And what I have to figure out is how fast is the shadow moving. Okay, so let's give something some names. Maybe S over here for shadow might make sense. And then I think it'll also be relevant how far this person is from the wall. So maybe I'll call that M for man, because the man is that far from the wall. Fine, whatever. And his height right here is 6. Okay, so the trick to this problem is to use similar triangles. I have this big triangle right here. Note that 200 goes all the way from here over to here. So this big triangle has a height of S and a base of 200. And this smaller, similar triangle right here has a height of 6 and a base of, well, it's not the full 200, it's 200 minus whatever M is. So I get this equation right here. And you could take the derivative of both sides here, but I think it's a lot easier to simplify before you do any calculus. Maybe cross multiply. Multiply both sides by 200 minus M. That gives me 200S minus SM is equal to 6 times 200 is 1200. And that just to make the calculus easier. When you're doing the calculus, the derivative of 200S is 200S prime. Minus, if I use the product here, I get S prime M plus M prime S. However, I want to subtract this thing. So, fine, I'll do it in 2 steps. You get something like this, and that equals 0. So now let's go back and see what we asked. How fast is the tip of his shadow moving down the wall? In other words, what is S prime? Almost S prime. We'll talk about that when we get closer. I want to find S prime. Well, what does it tell me? It tells me the man is walking towards the wall at a rate of 30 feet per second. M prime? Not quite. You might think that's M prime, but M is the distance this guy is from the wall. So this is the speed he's approaching the wall. In other words, M is getting smaller by this amount. So M prime would actually be equal to negative 30. So I go through and I plug that in, or maybe I solve first. Let's solve for S prime first. Do I know S? I guess I don't know S, so I'll have to figure that out. Let's find S. The way I can figure out S is using this equation. So I got that S over 200 is equal to 6 over 200 minus M. I'm trying to figure out S, the length of the shadow, when M is equal to 50. So it's 200 minus 50. So I got 150 S is equal to 1200. So S is equal to, what's that, 8? If you take 1200 and divide it by 15, 1200 divided by 150, you get S equals 8. And once you know that S equals 8, you can come over here and say, well, I'm going to algebraically solve this first. 200 S prime minus S prime M is equal to, note that if I take this negative and distribute it through, this becomes negative. But to move it onto this side, I'll add it to both sides. So I'll get M prime S positive. And so S prime, if I factor it out from this side and then divide by what's left, I get 200 minus M. And now, it's hard to read my writing, but this is supposed to say M prime S divided by 200 minus M is what S prime is equal to. And I think I have all these pieces. M is given to me to be 50. So I got 50 times S. All right, that should be M prime up on the top, not M. M prime is negative 30. S is equal to 8 divided by 200 minus M. M is 50. So I get negative 240 divided by 150. In other words, negative 24 over 15, which 3 goes into both of those, negative 8/5. So wait, what did you just figure out? S prime is negative 8/5. What that means is the length of the shadow is decreasing at a rate of negative 8 over 5. So shadow decreasing at 8 over 5. And my units here are feet per second. That would be the answer. This video is getting long, so I'll stop it here and make another one for the second half.